Welcome to Brain Vision.
There are two gravitational forces acting on particle A. One of those gravitational forces comes from particle B and another one from particle C. So I labeled FBA, the gravitational force acting on particle A, as an effect of the mass of particle B. Similarly, I labeled FCA, the magnitude of the gravitational force acting on particle A because of the mass of particle C. Now we proceed to calculate the magnitudes of these forces. The magnitude of the force provoked by particle B on particle A is equals to G times the mass of particle B times the mass of particle A divided by the distance between particle B and particle A squared. Then, plugging in the values that were given in the problem, we get that FBA is equals to 6.67 times 10 to minus 11 times 363, which is the mass of particle A, times 517, which is the mass of particle B, divided by the distance between particles A and B. And we can see in the figure that this distance is equals to 0.5 meters. So we have 0.5 squared down here. And this gives us a gravitational force of approximately 5.007 times 10 to minus 5 newtons. Now for the magnitude of the gravitational force between particle C and particle A, we have the following. FCA is equals to G mc times ma divided by the distance between particle C and particle A squared. Then, by plugging in the values that were given in the problem, we get the following. FCA is equals to 6.67 times 10 to minus 11 times 154 kilograms times 363 kilograms divided by the distance between particles A and C. And the distance between particle A and C is equals to 0.5 plus 0.25, which is 0.75. So we have 0.75 squared down here. And this gives us a gravitational force of approximately 6.629 times 10 to minus 6 newtons. Now let me organize the board. Now I have to choose a reference to calculate the net force. So I will choose that everything that is pointing to the right is positive, and as a consequence, everything that is pointing to the left is negative. Therefore, the net gravitational force that is acting on particle A is given by FBA plus FCA, because both of these forces are pointing to the right. And this is equals to 5.007 times 10 to minus 5 plus 6.629 times 10 to minus 6. And this gives us a net force of approximately 5.67 times 10 to minus 5 newtons, and it's pointing to the right. For the next item, we have to calculate the magnitudes of the gravitational forces that the particle A exerts on particle B, and the magnitude of the gravitational force that particle C exerts on particle B. To begin with, note the following. The magnitudes of the gravitational forces are symmetric. I mean that the magnitude of the gravitational force that particle A exerts on particle B is equals to the magnitude of the gravitational force that particle B exerts on particle A. So we do not need to calculate these again. We had already calculated the magnitude of the gravitational force that particle B exerts on particle A. So we can just use this value again because of the symmetry on the magnitudes of the gravitational force. So I'm not calculating it again. The only thing that we have to calculate this time is the magnitude of the gravitational force exerted on particle B by particle C, because we haven't calculated it yet. Then we have the following. FCB is equals to G times the mass of particle C times the mass of particle B divided by the distance between particles B and C squared. By the figure, we can see that the distance between particles B and C is equals to 0.25 meters. So, by plugging in the other values that were given by the problem, we get FCB as being equals to 6.67 times 10 to minus 11 times 154 times 517 divided by 0.25 squared. And this gives us a gravitational force of a magnitude that is approximately 8.497 times 10 to minus 5 newtons. Now let me organize the board before finishing this item. Okay, so the net force that acts on particle B is equals to FCB, that is pointing to the right, minus FAB, that is pointing to the left. And this is equals to 8.497 times 10 to minus 5 minus, remember that FAB is equals to FBA, and FBA is equals to 5.007 times 10 to minus 5. So we have 5.007 times 10 to minus 5 here. And this gives us a net force of approximately 3.49 times 10 to minus 5 newtons to the right. Now let me clear the board for the next item. On the last item, we have to calculate the magnitudes of the gravitational force exerted on particle C by both particles A and particle B. Now remember that the magnitude of the gravitational force is symmetric, then FAC is equals to FCA, and we had already calculated FCA on the first item, it's here. And also FBC is equals to FCB, and we had calculated FCB on the second item. Therefore, we do not need to calculate any gravitational force again, and we can proceed already directly to the net force. So the net force that acts on particle C is equals to, as both forces are pointing to the left, both forces will have a minus sign. Therefore, we have minus FAC minus FBC, and this is equals to minus FAC, which is 6.629 times 10 to minus 6, minus FBC, which is 8.497 times 10 to minus 5. And this gives us a net force of approximately minus 9.16 times 10 to minus 5 newtons. Of course, we have a minus sign here, therefore this net force points to the left.